Welcome to my notes Oracle DBA YouTube channel. In this video, we are going to discuss about parallel sequential scan. So, what are the topics we are going to learn in this video? What is a parallel sequential scan and when to use the parallel sequential scan? How does it works? What are the key parameter we have to tune for that? And we are going to see the practical demo. Let's deep dive into this session. So, what is a parallel sequential scan? A parallel sequential scan in a PostgreSQL, a query execution strategy that divides work of large scanning table among multiple worker process. Each worker scans segment of the table and the leader process gathers and merges the result. This approach leverages multi-core CPU to speed up the larger data retrieval and processing the tasks. So you got the point, right? So as a definition, so parallel sequential scan is nothing like that. It's you are using a multiple CPU cores to retrieve the data and processing the tasks, which is specially for larger data sets or the data warehouse environment. So the next thing is, when should we have to use? So as I mentioned earlier, this parallel sequential scan is majorly used in the when the table contains of millions or billions of row, and second thing is when most or all rows are returned or no suitable indices are exist on the table. Also, we can use for reporting and data warehouse environment or aggregations. For example, you table have contains a large of aggregations, so you want to sum up with the last 5 years data and you want to do the calculation implementation. So another thing is batch processing. You may execute the batch queries. So those queries, parallel sequential scan is apt for that. And the second thing is when your system have a enough CPU cores and memory to support a parallel workers, then you can go for the parallel sequential scan. So parallel sequential scans are less effective for small tables or the query returns few rows. So as the overhead, coordinating workers can override as a benefits. So far we understood what is a parallel sequential scan and when to use for a parallel sequential scan. We got that. Next thing is, how does the parallel sequential scan works? So the parallel sequential scan works as a four to five stages, which is like a query planning and the worker allocations and sequential scan, parallel execution, result collection, and resource management. So based on my understanding, I have created this diagram. So in the query planning, the query planner evaluates whether a parallel scan is beneficial based on the table size, selectivity, and available resources. If a chosen gather or gather merge node is included in the plan. Worker allocation. So how the worker allocation will be done? So there is a parameter called max parallel worker per gather. Leader process to start up with this parameter based workers. Each worker is assigned a range of table blocks to scan. Parallel execution. Workers can scan the segments, apply the filters, send back the result to the leader. The leader may also participate if the scanning, the parameter is called parallel leader participation is enabled. And the next step is result collection. The leader collects and merge the results from all workers for aggregation, worker performer, partial aggregates, and the leader finalize them. Resource management. So far we know that the CPU has assigned the worker process, but we need to know that how it maintains the resource management. The number of workers is limited by max worker process. By default it is 8, and the another parameter is max parallel workers per gather. The planning consideration, the cost of launching worker is parallel setup cost and transferring the tuples based on the parallel tuple cost. So far we understood like how does it works. Next thing is, what are the key parameter has to tune for this? So the as I mentioned earlier, there are certain parameters. One is like a max parallel worker per gather. Maximum workers per parallel operation has been assigned. By default, it is 2. Parallel setup cost. Cost of launching workers and initialize shared memory. By default, it's 1000. Parallel tuple cost. Transferring a tuple from worker to leader. Default value is zero point 0.1. Parallel table scan size. Minimum table size for the parallel sequential consideration. By default, it value is 8 MB. Parallel leaders participation, whether the leaders participates in the scanning or not. By default, it has been enabled. Max worker process. Max worker process system wide maximum background workers has been allowed. So by default, it is 8. The latest version is 17 and beta was 18 has been released. So here actually we can see some of the improvements. The first one is improved parallel query processing. The query planner is smarter about when to use the parallelism, especially for large data sets and complex operations. Parallelism is now available for more operations, including indices, joins, and even some maintenance tasks like vacuum. Better memory management. Memory usage during parallel execution is optimized, reducing overhead and allowing more efficient use of system resources. Enhanced performance for large tables. Parallel scan joins and aggregates are more efficient with significant performance gains reported for analytical and data warehouse workloads. Optimized resource utilization. The system better manage worker allocation and cleanup, reducing congestion and improving stability. So, it supports extension like PostGIS and PG Vector take advantage of parallel query execution for both queries and indices build. For that, I'm going to share my screen. Let's see in the demo. Let's create a database psec. So I'm connecting this psec. So for this, we can create a table on this. Now we can load a data. The insertion is taking a time. Let's verify that. So you can see that particular table is using the sequential scan enabled. So we have to just cross verify all the parameter value once again as mentioned earlier. So you can see here that max worker process is 8, and this min table scan is 8 MB, and parallel setup cost is 1000, and parallel tuple cost is zero point 0.1, and max parallel worker per gather is 2. Now orders. So once the analysis has been done, let's verify that. So you can see here, so previously that query was used as a sequential scan on the order table. So you can see that uh, almost there was 27,967 rows has been retrieved, but here almost 1,78,000 rows are retrieved, and you can see that there is a slight cost variation also there. So here actually it uses 17,011, and here it is uses 90,001. And also you can see that there was used like a 2 worker node has been uh, assigned for this. Let's add the analyze over here. So here actually you can see that the execution time was 60 milliseconds. Now, so whether I can increase my parallel worker per gather process or not. So you can do the trial and error, but we can increase this value up to max worker process. So what I'm going to do, I am going to just change this value into 4. Now let's say, so even though that worker has been added, now the execution time has been increased compared to this one. And that you can see here the number of rows retrieval has been reduced because of the worker has been added, so which reduce that uh, uh, the row retrieval. And you can see that there was like 17,018. So what if I have increased into 6? So I have added that number of worker process, but still you can see that it execution time was increased. So let's tune that other values. So once I have tuned the other values, you can see here which the execution time was reduced from 102 to 44 milliseconds. So the end result is, whenever you are tuning your parallel sequential scan, you should not only rely on the max parallel worker per gather as well. So you have to tune the other parameters. Why we have to tune? As I mentioned earlier, these are the parameters where the parallel tuple cost is nothing like that, which mentioning how many uh, transferring tuple for each worker to leader node. And that parallel setup cost, which used to cost of launching a worker initialized shared memory. So we have to consider this parameter as well. So once you done, uh, we can see that result. So and also there is one main thing is there. The thing is, so the cost was determining divided off among that the parallel setup cost, as I just shown here, right? The parallel setup cost, and uh, that parallel tuple cost, and that number of workers is bound with that parallel. So you want to improve your parallel thing, you have to tune this all these three parameters. And also if you are using a high frequency multiprocessor, then you have to lower the value of parallel setup cost and parallel tuple cost, will help to selection of parallel scans. If there are not many processors running in parallel, then we have to increase the value of parallel worker per gather, can leverage more parallel processors to improve the query performance. And another point is, so the value of a number of worker is future further capped by max worker process. That's what I mentioned in that in between the video. So the value is depends on max worker processes. So you can increase the value based on that this value itself. And also you have to consider this um, your CPU course as well before you are doing it for your performance. So as a general practice, whenever you are performing this kind of tuning, first you can implement on your lower environment. Based on the test case result, you can tune the value and set the same value into your production environment. I hope this video has been clear. So for more videos, you can subscribe to my channel. Thank you.